Welcome back to the advent of agents. Today, we are talking about taking AI to production scale. When developers first build autonomous agents, they naturally start with an interactive synchronous loop. The agent picks up a document, reads it, processes it, and moves on to the next one. But what happens when you need your agent to process an entire cloud storage bucket with 10,000 PDFs? Forcing an agent into a real-time synchronous pattern at that scale is a trap. You run straight into throttled API limits, broken client connections, and absolutely massive token costs. The solution isn't to increase your rate limits. The solution is to change the architecture. To achieve true scale, you need to shift to the agent as orchestrator pattern. Rather than forcing your agent to read documents one by one in memory, you equip your agent with a tool that interfaces directly with the backend infrastructure. When the agent receives a massive job, it aggregates the data, bundles instructions, and offloads it into a managed job queue using Gemini Batch API. By processing asynchronously, you eliminate connection drops and get a 50% reduction in token costs compared to standard LLM calls. Let me show you exactly how this is implemented using Gemini Python SDK. First, we need data. Here, we are simulating a large payload by fetching the top stories live from Hacker News API. To feed the batch API, we must structure our inputs into JSON-L format, JSON lines. Notice the structure being written out. For each story, we pass a request object perfectly matched to our execution prompt. Once your dataset is formatted, we don't perform inference right away. First, we use client.files.upload to securely push the massive JSON-L chunk directly to Google's backend servers. The infrastructure now holds the data. Here is where the magic happens. Instead of calling generate content in a loop, we call batches.create. We pass in our required model string like Gemini 3.1 Pro Preview, which supports the batch API. We then point the source argument directly to the URI of the file we just uploaded. At this exact moment, the orchestrator agent's job is completely done. It has bundled the data, passed the instructions, and successfully pushed the workload into flex execution. The session can now safely terminate. Let's actually run it. I'll execute my batch processor.py script. We see the script fetches the Hacker News data, creates the JSON-L structure, and uploaded it. And there's our prompt. Batch success, batch job submitted successfully, right? Current state of the job is pending. This is completely normal and is actually the exact behavior you want. The entire reason the Gemini Batch API gives you a massive 50% token cost reduction is precisely because it runs on background lower priority instructions. When you submit a job, it enters a global queue with job state pending, and Google executes it dynamically as compute frees up. For a tiny 5 item list, it usually takes anywhere from like 5 to 10 minutes to move to job state succeeded. For a massive 10,000 page data set, it might run asynchronously overnight. When it shows pending, it physically proves the point. The orchestrator agent successfully offloaded the work to Cloud Queue. And there it goes. The job is queued at a 50% discount, and our agent session is safely terminated. We can close our laptop right now, and the job will still finish. That's batch processing. You have successfully upgraded your agent from a synchronized bottleneck into an asynchronous orchestrator. You can find the copy pastable code snippet below alongside links to the ADK documentation. Happy coding and see you tomorrow on day 27. Bye.